We're continuing work on this paper, trajectory determined by a snapshot at a finite hyperreal time. I realized that in the hyperreal section, the discussion about justifying filling in the positions of the balls is a little more complicated than necessary, because we know the general form of the height functions because the balls are governed by y prime prime equals minus mg. So we're going to fix that, and then we're going to fill in references, and we're going to write the abstract. And yeah. So in the section on hyperreals, we introduce the transfer principle. Then we say another example of the transfer principle, very relevant to us here. And this whole paragraph and the next paragraph are kind of overcomplicated. Another example of the transfer principle, very relevant to us there, let's see. Rather than closing the colons, I want to say another example of the transfer principle is very relevant to us here. And then I will say that the height of the thrown ball, the height of a ball governed by, let's see, according to Newton's second law, if gravity is the only relevant force, then the height of a thrown ball, then the height of a ball thrown vertically satisfies the ODE y double prime equals minus mg equals minus mg. This ODE, the solutions to this ODE are precisely the functions of the form. The functions y from the solutions so over the reals, the solutions to this ODE are precisely the functions y reals to reals of the form y of t equals minus 1/2 mgt squared plus v0t plus y0, where v0, y0 in the reals are the ball's initial velocity and initial height respectively. This fact is expressible in first order logic, and thus by the transfer principle. The same we know that we can infer by the transfer principle the solutions to this ODE over the hyperreals are precisely the functions y from hyperreals to hyperreals of the same form where v0, y0 are in the hyperreals. No other solutions exist. And that replaces this whole paragraph. Should we keep this parenthetical about the stronger statement? I don't really think we need it. I'll comment it out for the moment. Leave it in a commented out form. But we should note that, of course, for any v0, y0 in the reals, which is a subset of the hyperreals, well, I don't need to say that it's a subset of the hyperreals. For any v0, y0 in the reals, T maps to, well, let's say T in hyperreals maps to minus 1/2 mgt squared plus v0 t plus y0 is an extension of T in the reals maps to minus 1/2 mgt squared plus v0 t plus y0. Is that an of course, or is that an also, or an and? And for any v0, y0 in the reals, the hyperreal function is an extension of the real one. Now, this next paragraph, starting on line 158, I think is also completely eliminatable. Yes. And then the above is just a very formal technical way of justifying talking about the ball's height at non-real hyperreal times. Not only does the ball have heights at non-real hyperreal times, those heights obey the same exact ODE which governs the ball's heights at real times. Thus, we extend the motion of the ball into hyperreal times in such a way as to respect the laws of physics. We are not arbitrarily filling in the gaps. Newton's second law fills them in for us in a physically realistic way. Let me further drill into this. What I'm saying is, a priori, the decision to use the same position function minus 1/2 mgt squared plus v0 t plus y0. The decision to extend the position function from into the hyperreals might seem arbitrary, but in fact it reflects Newton's second law and the force of gravity. It is physically realistic in that sense. Okay. Let's commit that. For the commit message, I will write simplification of transfer principal application. Okay. Now the time has come to fill in the references. The paper which we referred to, which we wrote a couple of years ago, which motivated all this, is hyperreal differentiation with an idempotent autofilter. I'm going to go to scholar.google.com. Search for hyperreal differentiation with an idempotent autofilter. Why is it showing the archive version? We want the version in Journal of Logic and Analysis. Yeah, and then copy the bibtec. Save this as snap.bib. Alexander 2024 hyperreal. Add in the LaTeX code to typeset the bibliography. I don't remember the exact format, so I'm going to copy it from another paper on my other monitor here. Bibliography style plain bibliography snap. Let's try compiling now. We're going to have to upload snap.bib. Okay, beautiful. We have a bibliography. We also need to cite Robinson. Robinson non-standard analysis. Grab the bibtec for that. Paste that into snap.bib. We can also mention Goldblatt's textbook. Lectures on the hyperrails. Whoops. I just pasted the whole bibliography file. I meant to paste the bibliography file into snap.bib and then paste the label and cite the label. Any other? No, just the abstract. Now, it's very silly to only have 3 items in the bibliography. What else can we cite? This is about prediction, we could cite that paper that we read on the channel the other day about the perfect prediction theorem. It's sort of spiritually similar. It's not directly similar. Let's typeset this. Paste the bibliography, paste the main manuscript. Now our bibliography has 3 items. Oh, by the way, I was also thinking it might be worth pointing out, you know, there's this folk tale about how the Pythagorean cult believed all numbers are rational. So when we're talking about extending physics to the hyperreals, that could be something relevant to mention. But where would we put it? We could either put it here on line 100, make it a footnote, modify the line slightly to give a hook for the footnote, or perhaps in the introduction. Introduction. Suppose someone throws a ball in the air and takes a photograph of it, etc. Assume that the physics of our universe is such that at every real valued time the height and velocity of this ball are real valued. And assume that the differential equations governing the ball's height are valid not only at real times t, but also at times t plus epsilon, whenever epsilon is a positive or negative infinitesimal. Perhaps here? Where to put a reference to the Pythagorean cult? Perhaps add a new paragraph at the end of the introduction. We could say, critics critics might be skeptical about the physical reality of times of the form t r plus epsilon. Uh-oh. The physical reality of times with infinitesimal components. The question of whether or not the real numbers exhaust all physical times is one which seems inherently unfalsifiable. We are such critics. I don't want to say this in a way as to insult the critics. I'm tempted to say such critics remind us of the Pythagorean cult, but that could sound sort of insultive. In parentheses we say, in contrast to the earlier Pythagorean cult belief that all numbers are rational, which is falsifiable and has been falsified. Yeah, I think that's a good way to say it. Critics might be skeptical about the physical reality of times with infinitesimal components. The question of whether or not the real numbers exhaust all physical times is one which seems inherently unfalsifiable, in contrast to the earlier Pythagorean cult belief that all numbers are rational, which is falsifiable and has been falsified. Maybe I should weaken this. Delete that clause, just say in contrast to the earlier Pythagorean. In contrast to the earlier Pythagorean cult belief that all numbers are rational. Yeah. Yeah, by not explicitly making the comparison, but just mentioning the Pythagorean cult belief, you know, the reader can connect the dots themselves and nobody is insulted. Anyway, I should also use a similar technique I used in my 2013 math bio paper. You know, such critics, you know, maybe there's some critics who think it's ridiculous to talk about physical times with infinitesimal components. Well, such critics can derive value from this paper as well, because they can view the paradox in this paper as proof of their position by contradiction. Critics are strongly resistant to physical times with infinitesimal components. Can read this paper as an argument against such times. If one takes it as axiomatic that a single snapshot cannot determine the trajectory of a falling ball of the ball described above, then the paradox presented in this paper could be interpreted as evidence against the physical existence of times with infinitesimal components. Critics might be skeptical about the physical reality of times with infinitesimal components. The question of whether or not the real numbers exhaust all physical times is one which seems inherently unfalsifiable, in contrast to the earlier Pythagorean cult belief that all numbers are rational. Critics who are strongly resistant to physical times with infinitesimal components can read this paper as an argument against such times. If one takes it as axiomatic that a single snapshot cannot determine the trajectory of the ball described above, then the paradox presented in this paper could be interpreted as evidence against the physical existence of times with infinitesimal components. Okay. Oh. I forgot to get add snap.bib. I really should have committed earlier. Now the commit is really committing two things at once. Add some references and add another paragraph to the introduction. Okay. The bibliography still only has 3 references. We could fluff it up perhaps by looking for a reference about Pythagorean belief that all numbers are rational. Who do you cite for that folktale? Pythagorean mathematical idealism and the framing of economic and political theory. Lore and science in ancient Pythagoreanism. The irrational, a story of the numbers you can't count on. The Pythagorean theorem, a 4,000-year history. Pythagoras, everyone knows his famous theorem, but not who discovered it. All his number, basic doctrine of Pythagoras. A lot of crack pottery. Pythagorean number doctrine in the Academy. Pythagorean number mysticism in the Renaissance. A symbolic interpretation of Pythagorean number. The critical analysis of the Pythagorean theorem. Origin of rational numbers and their approximations. Pythagorean number theory and its implications for psychology. What? A Pythagorean introduction to number theory. The Pythagoreans' number and numerology. Review of Aristotle's claim regarding Pythagoreans' fundamental beliefs. All is number. The Pythagoreans in Greek mathematics. Oh, this is kind of a dead end. Let's see what an AI would say. Oh, we need to have an AI look at the paper anyway. Let's download a copy of the PDF. Attach the PDF to a conversation with GLM 4.7 and prompt the AI. Analyze the attached draft, which I am preparing for submission. Give me suggestions on ways to improve it. Target would be probably something like the mathematical intelligencer, although I'm open to any suggestions you might have about venues. Point out any mathematical or other flaws. Suggest possible additional additions to the bibliography. Okay. AI is thinking. The Google Scholar bibliography item for Goldblatt is kind of messed up with this volume 188 business. Let's delete that volume line there. And let's change the publisher to just Springer. How's the AI doing? Okay, good. The AI finished thinking. The AI says, "This is a charming paper." Wait, can I make the text larger? Yes. The AI says, "This is a charming paper. It addresses a physics puzzle using non-standard analysis in a way that is both mathematically rigorous and intuitively surprising. The connection you draw to the algebraic/transcendental analogy in section 2 is excellent. It grounds the non-standard result in a classical number theoretic context that is easier for many mathematicians to grasp immediately. Here's a detailed analysis, suggestions for improvement, and comments on venues. Overall impression and target venue. The mathematical intelligencer is an excellent choice. The paper fits the note or mathematical community section format perfectly, is short, relies on a clever insight rather than a heavy machinery, and touches on the philosophy of mathematics/physics. Why it fits, the intelligencer values exposition, historical context, and paradoxes that illuminate mathematical truths. Alternative, the AMM, yeah, sure. Snowball's chance in hell of getting in there. Or Mathematics Magazine. Specific suggestions for improvement, the abstract. The draft currently omits the abstract. Yeah, of course. No. I will completely ignore the AI's recommended abstract. I'm going to write that myself. The algebraic precedent. The logic in this section is sound, but there's a calculation error in the examples given for the standard case t equals 1. Flaw. You write, if y of 1 equals 5, then the ball's trajectory could be y of t equals minus 1/2 gt squared plus 1t plus 4 minus 1/2 g. Let's test this at t equals 1. Y of 1 equals 5 minus g. You have the signs mixed up in the constant term relative to the velocity term. Hmm. 5 minus g. See, I'm terrible at just like actual arithmetic, like the kinds that they make 6th graders do. Oh, it offers a correction. If the trajectory is minus v, oh, example 1, y0 equals 5 plus 0.5 g minus 1. Change 4 minus 1/2 g to 4 plus 1/2 g. Four minus to 4 plus. Okay, so if we plug in 1, we get minus 1/2 g plus 1 plus 4 plus 1/2 g. Oh yes, the AI was correct. I did indeed have a sign error in both places. And if we plug in 1 here, minus 1/2 g, oh, this should be gt squared, another error there, plus 2 plus 3 plus 1/2 g. Yep. Refining the algebraic argument. The sentence implying in particular that the constant g of gravity is algebraic is correct, but dense. You might explicitly state, since t equals 0 is algebraic, the height y of 0 equals y0 must be algebraic. Since t equals 1 is algebraic, y of 1 equals minus 1/2 plus v0 plus y0 must be algebraic, which implies v0 and g are algebraic. The reader can figure that out. There's no need to go into that much detail about that. The hyperreals and the proof. The proof is correct and elegantly simple, however, you rely implicitly on the continuity of the extension of the functionality. While this follows from the transfer principle, stating it explicitly adds rigor. You're right, since ab's standard part of t minus t less delta for all real delta bigger than 0, continuity of y implies. I suggest changing this to, since y is a polynomial, its extension to the hyperreals is big S continuous. Because ab's standard part of t minus t is infinitesimal, it follows that dot dot dot. The derivative step, you state, thus by definition of y prime of standard part of t, abs y prime of standard part of t minus y of standard part of t plus h minus y of standard part of t all over h less than epsilon for all real epsilon bigger than 0. This is true, but it relies on the standard limit definition. In a non-standard context, you can invoke the standard part theorem or Kiesler's theorem. If f is differentiable at x, then for any infinitesimal big delta x, f of x plus delta x minus f of x quantity over delta x is approximately f prime of x. This shortcut is standard in non-standard analysis literature. Is that a contradiction, to be standard in non-standard analysis literature? Likely Kiesler. And would clean up the epsilon delta language in the proof, making it feel less analysis heavy and more non-standard flavored. Yeah, but it also makes it less self-contained. But it is good to mention. It might be good to parenthetically mention that. Anyway, when we use the continuity of y, continuity of y implies continuity of y, let's put in parentheses, which we may use by the transfer principle, or which holds by the transfer principle. I mean, y is a polynomial. You could explicitly compute everything. Anyway. And then let me just check, is this true what they say about Kiesler's theorem? You know, maybe the AI is hallucinating it. I'm not seeing references to this, which doesn't imply the AI is hallucinating it, but I'll err on the side of caution and not mention it. Discussion section 5, n-body problem. The generalization to the n-body problem is a nice touch. It emphasizes that the result relies on the parameters being real, not on the simplicity of the quadratic. The paradox. You might want to briefly explicitly mention why this feels like a paradox. It is because the hyperreal number carries two pieces of information, its shadow, the real time, and its halo, the infinitesimal offset. The infinitesimal offset effectively encodes the derivative information that is usually lost in a single snapshot. Yeah, I don't think I need to mention that. Mathematical or other flaws. Aside from the algebraic sign error, there are no mathematical flaws. The logic holds up well. One minor logical point regarding the introduction. You mentioned the time step has t-snap attached to it. For the proof to work, the observer must know that t-snap is a finite non-real hyperreal. Specifically, they must know its standard part and the fact that it is non-real. Yeah, this is an example where the AI fails to understand what's going on. If the observer just sees 5, then that's not the hypothesis. The hypothesis is that the timestamp is a non-real hyperreal, a finite non-real hyperreal. So the observer wouldn't see just 5, they would see 5 plus epsilon. Suggestion, you might want to add a parenthetical assuming the timestamp on the photograph is readable and reveals the time to be. Well, yeah, of course the timestamp is assumed to be readable. That goes without saying. Your current bibliography is minimal but functional. For a venue like the Intelligencer, adding a few more references could help pad the paper and show where it sits in the literature. Kiesler, elementary calculus, and infinitesimal approach. Hirsch, some proposals for reviving the philosophy of mathematics. You might cite a standard text for Lindman's theorem or transcendental number theory if you want to be formal about the algebraic sentence, but it is likely unnecessary. Yeah. Okay, so we fix a sign error. Fix a couple mathematical flaws. Then add snap.pib. Fix the Goldblatt bib item. Yeah. Okay. Okay, let's write the abstract. Abstract. Knowledge of the position of a falling ball at one real valued time. I mean, the reader immediately gets confused because, you know, there's sort of this latent background assumption that everything in physics is real valued. One snapshot giving time and position of a ball falling subject to gravity and Newton's second law is generally, let's see, if a ball is falling subject to the force of gravity and Newton's second law, then one single snapshot providing position and time, one single snapshot, parentheses, one given position at one given time, is insufficient is generally considered not enough information to infer the ball's entire trajectory. Paradoxically, we show that if the time in question is a finite non-real hyperreal time, for example, an infinitesimal time, or a time of the form, say, 5 plus epsilon, where epsilon is infinitesimal. And if we assume that at every real valued time, the ball has real valued position and velocity, let's see, strike paradoxically at the beginning of the sentence, put it here on line 28, then paradoxically the snapshot does determine the entire trajectory. This last sentence is very long. Let's try and break it up. But suppose that the given time in question is a finite non-real hyperreal time, for example, an infinitesimal time, comma, or a time of the form, say, 5 plus epsilon, where epsilon is infinitesimal. And assume that at every real valued time, the ball has real valued position and velocity. Then paradoxically, let's see, paradoxically, well, change supposed to assume. Paradoxically, under these two assumptions, the given snapshot does determine the ball's entire trajectory. Good. Commit that. It just occurred to me, perhaps one way to find items to add to the bibliography is we can go look at my paper, Hyperreal Differentiation with an Item-Potent Ultrafilter. Maybe if I look in this paper's bibliography, that'll give me an inspiration. Topological partitions, irrelevant. Remarks on an arithmetic derivative, irrelevant. Ultrafilters, IP sets, etc., irrelevant. Arithmetic differential equations, irrelevant. Differential calculus with integers, irrelevant. Foundations of arithmetic differential geometry, irrelevant. Model theory, concrete mathematics. Is there a reason to cite concrete mathematics? No, not really. Algebra in the stone check compactification, irrelevant. Differentiating by prime numbers, irrelevant. Well, actually, it's kind of a stretch, but it would be true to mention that the work that we did on this well-definedness problem was motivated by this paper of Jeffries in the notices. Yeah, let's do that. Differentiating by prime numbers. Differentiating by prime numbers. Cite, BibTeX. We were originally motivated to think about this topic after considering certain well-defined questions about hyperreals. Motivated by Jeffries 2023 differentiating. Let's make that a footnote. Footnote. Motivated by this. Published in blah. Yeah. Okay. Let's compile. Great, now our references contains 4 items. All right. Okay, now let's use AI again. This time, by making the font size larger, it removed the attachments button. That's annoying. This time I'm attaching the latest draft and I'm going to say, I am a reviewer charged with reviewing the attached paper for the mathematics intelligencer. I want to decline the paper. My gut feeling is that it's junk. Help me justify reasons to recommend rejection. and see what the AI will say about that. The idea being obviously that whatever the AI suggests as reasons for rejection, we can consider as things that might need changing. Meanwhile, while that's running, let's do some proofreading. Trajectory determined by snapshot at a finite hyperreal time. Abstract. If a ball is falling subject to the force of gravity and Newton's second law, then one single snapshot, one given position at one given time, is generally considered not enough information to infer the ball's entire trajectory. But assume that the given time in question is a finite non-real hyperreal time, for example an infinitesimal time, or a time of the form, say, 5 plus epsilon, where epsilon is infinitesimal. And assume that at every real valued time, the ball has real valued position and velocity. Paradoxically, under these two assumptions, the given snapshot does determine the ball's entire trajectory. How's the AI doing? Still thinking. Introduction. Suppose someone throws a ball in the air and takes a photograph of it in the air. They give you the photograph, which has a timestamp attached to it, so you know the height of the ball at a given time t snap. Assuming that the ball's motion is governed by Newton's second law of motion, force equals mass times acceleration, and that gravity is the lone force acting on the ball, can you deduce the ball's entire trajectory? Usually the answer is an emphatic no. But could there be some context in which the answer is yes? Assume that the physics of our universe are such that at every real valued time, the height and velocity of this ball are real valued. And assume that the differential equations governing the ball's height are valid not only at real times t. Wait, in the abstract, did I say? Yes, position and velocity. Assume that the physics of our universe are such that at every real valued time, the height and velocity of this ball are real valued. And assume that the differential equations governing the ball's height are valid not only at real times t, but also at times t plus epsilon, whenever epsilon is a positive or negative infinitesimal. We will make this more formal below. This assumption is a mild assumption because of the so-called transfer principle from non-standard analysis, which we will also discuss below. Believe it or not, from the above assumptions, it follows that if our timestamp t snap happens to be a finite non-real hyperreal, in other words, if t snap equals t real plus epsilon for some real t real and some positive or negative infinitesimal epsilon, then in fact the snapshot does determine the entire trajectory of the ball. Critics might be skeptical about the physical reality of times with infinitesimal components. The question of whether or not the real numbers exhaust all physical times is one which seems inherently unfalsifiable, in contrast to the earlier Pythagorean cult belief that all numbers are rational. Critics who are strongly resistant to physical times with infinitesimal components can read this paper as an argument against such times. If one takes it as axiomatic that a single snapshot cannot determine the trajectory of the ball described above, then the paradox presented in this paper could be interpreted as evidence against the physical existence of times with infinitesimal components. How's the AI doing? It's done. Let's look what the AI says. Your gut feeling is well founded. While the mathematics in the paper is technically correct, it is a valid, albeit trivial, application of the standard part map. The paper wraps a mundane definition in a cloak of physical paradox and profoundness. It is essentially a look what I can do with infinitesimals trick that relies on misleading the reader about the information and content of a snapshot. Here's a breakdown of the rigorous objective reasons you can use to justify recommending rejection to the mathematical intelligence editors. Mathematical triviality, lack of novelty. The central claim of the paper is that knowing the ball's hyperreal position, y of t real plus epsilon, determines its trajectory. However, this is just a trivial restatement of the non-standard definition of the derivative. In non-standard analysis, the value of a standard differentiable function at t real plus epsilon encodes both the function's value and its derivative at t real. Yes, that is true. Specifically, y of t real plus epsilon. Wait, its value and its derivative at t real. Well, certainly at standard part of t real. I'm not sure about at t real itself. Specifically, y of t real plus epsilon equals y of t real plus y prime of t real plus times epsilon plus big O of epsilon squared. Yeah, the big O of epsilon squared means it's not determined. It's determined up to this big O. but the standard part of TR is determined. The author's proof merely extracts the constant term to get y of TR and the coefficient of epsilon to get y prime of TR. Yeah, that's a more accurate statement. Stating that y of TR and y prime of TR determine the trajectory of a second-order ODE is day one of an introductory differential equations course. The author has simply obfuscated this trivial fact by encoding the two initial conditions into a single hyperreal number. Yeah, guilty as charged. Misleading physical framing such category error. The paper frames the result as a physical paradox. Usually a snapshot doesn't determine the trajectory, but under these assumptions it does. This relies on a deliberate equivocation of the word snapshot. I think this might be getting to some actual meat. Maybe this is some actionable changes we can make. A physical or real valued snapshot gives you one piece of data, position. A hyperreal snapshot gives you two pieces of data, position and velocity, encoded as the infinitesimal variation. Well, yeah, but that's the whole point of the paper. Claiming that a hyperreal snapshot determines the trajectory is like claiming that a photograph that magically also records the exact speed of the ball determines the trajectory. It's not a paradox, it's a tautology. The paper conflates the mathematical encoding of velocity within a hyperreal number with the physical measurement of position. Yeah, is it worth pointing out that it would be physically impossible to actually take this snapshot using the apparatus which we have available to us, assuming that we ourselves exist in the real numbers strictly? I don't think that's necessarily something that needs to be pointed out. And again, it is assuming that we ourselves live in the reals. The paper conflates the mathematical encoding of velocity within a hyperreal number with the physical measurement of position. Flawed physical implications, the discussion section. The author suggests that if one takes it as axiomatic that a single snapshot cannot determine a trajectory, then this paper serves as evidence against the physical existence of times with infinitesimal components. This is a massive non sequitur. The reason a real snapshot doesn't determine a trajectory is because it only measures position. If a real valued snapshot could somehow measure both position and velocity simultaneously, it would also determine the trajectory. The author's conclusion confutes the limits of measurement precision, extracting the standard part versus the infinitesimal part, with the ontology of time itself. No, I don't think so. Yeah, but maybe it's worth mentioning that, yeah, what we're essentially saying is that the value of the differentiable function at a finite non-real hyperreal time does indeed encode the position and the derivative at the standard part of that time, and this is not new or surprising. Yeah, and I'm not claiming that it is, but maybe I need to make this clearer in the paper. Where would we put that? In the introduction, perhaps? If we add a new paragraph to the introduction, we could say something like, the argument in this paper essentially boils down to showing that the value of a differentiable function at a finite non-real hyperreal time encodes both the position and the velocity of, encodes both the value and the derivative of said function at a nearby, at the closest real time, at the nearest real time, at a nearby real time. This is not a difficult result, nor This is not a difficult result. And is well known to, and is, this is not a difficult result, semicolon. It is either well known or trivial to any mathematician working in non-standard analysis. The point of this paper is to showcase a surprising, the point of this paper is to showcase a surprising, to showcase a consequence of this fact, which is, which clashes with our intuition, with our physical intuition about time and space, our physical, just to say our physical intuition, full stop. The argument in this paper essentially boils down to showing that the value of a differentiable function at a finite non-real hyperreal time encodes both the value and the derivative of said function at a nearby real time. This is not a difficult result. It is either well known or trivial to any mathematician working in non-standard analysis. The point of this paper is to showcase a consequence of this fact which clashes with our physical intuition. Yeah, what else does the AI say? Inappropriate analogy. Section 2 attempts to draw an algebraic precedent using transcendental versus algebraic numbers. This analogy is entirely flawed and serves only to mislead the reader. The algebraic example works by restricting the parameter space, assuming the initial conditions v0, y0 are algebraic. The hyperreal result works via the local differentiability of the function in the standard part map. The two mechanisms are fundamentally unrelated. Including it makes the paper feel like it is throwing darts at the board to see what sticks rather than presenting a coherent mathematical ideal. Well, the way you prove the two results is completely different. But the nature of the two results is definitely related. Unsuitability for the mathematical intelligencer. The intelligencer seeks articles with mathematical substance, historical insight, or genuine pedagogical value that will interest a broad mathematical audience. This paper lacks all three. It presents a basic application of the standard part map as if it were a deep physical insight. The result is too trivial to constitute a research contribution, and the physical framing is too confused to serve as good expository writing. It might be suitable as a footnote or a 5-minute classroom exercise in an undergrad non-standard analysis course, but not as a journal publication. Yeah. You know, this language here really reflects a funny sort of quirk about academia, which is that, you know, saying that it could be suitable as a 5-minute classroom exercise in an undergrad non-standard analysis course, the way that is said is as if it's something very trivial. But, you know, the fact is there's quite a lot of very, very advanced papers which would not be so suitable. Being so suitable is a plus, not a minus, or at least ought to be viewed that way. You know, some academics are kind of snobby. What I'm trying to get at here is that, you know, if I come up with a result which then gets presented to undergrads, that means it's a wildly successful result. The fact it's being presented to undergrads means that it is a bigger deal than if it's not presented to undergrads. The only reason you'd think otherwise is if you judge results purely by how difficult they are. Anyway, minor errors / sloppiness. In the introduction, the author refers to the transfer principle. Oh, did I misspell? Principle. It is the transfer principle. The generalization to astrophysics in the discussion is hand-wavy and adds no value as it relies on the exact same tautological extraction of position and velocity. Suggested wording for your review. Let's read this. You can synthesize these points into a professional review. For example, while the mathematical steps in the proof are technically valid, the paper's central thesis relies on a trivial tautology disguised as a paradox. In non-standard analysis, knowing the exact value of a differentiable function at t plus epsilon is mathematically equivalent to knowing both the function's value and its derivative at t. The author's proof simply extracts these two pieces of information using the standard part map to then claim that a snapshot at a hyper-real time determines the trajectory while framing this as a physical paradox is a category error. The author has merely encoded position and velocity into a single hyper-real number and then extracted them again. Because the paper presents a basic definitional consequence of non-standard analysis as a profound physical result, and because its physical conclusions regarding the nature of time are logically flawed, I cannot recommend it for publication. Yeah, an interesting exercise. Commit that spelling correction. And what else did we change here? Oh, yeah, and cite Jeffries. Pick a spelling error and cite Jeffries. Okay. Wait a minute. Oh. Recompile that. Okay, this is a pretty good polished paper now, I think. I think I'm gonna stop there for today. I'll take some time outside of the live stream and think about what to do next. Whether to submit this somewhere, and if so, where. Or whether to send it to some colleagues and ask them for feedback. Anyway, I'm Dr. Samuel Allen Alexander, mathematician and philosopher. Please like, comment, and subscribe. I'll see you in the next video.